Okay, let's continue. Play slideshow. Okay. So let's remember the big picture, guys. The success of deep learning in perceptual tasks like vision tasks is largely due to its automation of the feature engineering process. So instead of handcrafted features, we have used these features. Okay. Well, as this success was achieved first by AlexNet like 8 years ago, it created a demand for architecture engineering, where increasingly more complex neural architectures were designed. Inception modules, whatever, mobile nets, they are all architectural handcrafted designs. So neural architecture search, the title of this week, is the process of automating this architecture engineering, guys. It's thus a logical next step in automating machine learning. Well, it is the natural way in academia. How do I know this? Because, well, 5 years ago, if you manage to find a nice architecture which will work better on a dataset, you'll be able to publish it. But today, handcrafted architectures, you won't be able to publish them in a proper journal. Today, if you want to publish something, you'll have to do neural architecture search. So that's the new thing, and that's the next big thing. So already by now, neural architecture search methods have outperformed manually designed architectures. And there's an example we are going to go over today before we understand what and how neural architectural search is, how it is utilized. Okay, so guys, this was the big picture. And if you look at this big picture, this is a picture for classification networks. Actually, deep learning is mostly working on classification networks still. There's a big field on segmentation as well, and object detection as well. But all of the networks in object detection and segmentation are constructed over classification networks. That's why looking at the classification network big picture, like in a graph like this, will give you an idea how the field is just moving on. So all these are handcrafted designs, guys. AlexNet and VGG here are not handcrafted designs. They're just simple serial layers. After that, like mobile nets or DenseNet or the other ones, they were handcrafted designs until people worked on neural architecture search, just like this one, guys. Neural architecture search, as you can see, has the best results. Well, it's not very computation friendly, but it has the best results. So this is the big picture. Okay, we've covered these, but now it is time to move on to neural architecture search, in which we get better results with architectures which are not transparent to us, which are not handcrafted by us. Okay, let's continue in neural architecture search. Well, guys, I always recommend this. There are very nice blogs. In deep learning, especially in San Francisco, the best computer scientists and engineers of the world are working on that. They have this. They are the new generation, the generation Y, and they are the generation who were children when internet came, not like the X generation like us, because when internet came we were adults. So writing blogs or publishing what they know in the internet is something natural to them. That's why, since this field was born in their hands, there are very nice blogs about everything you can think about deep learning. So if you're interested in something in deep learning, be it neural architectural search or something else, towards data science or some other common blog services, websites, you'll find a perfect article talking about it in simple terms. Because these blogs are usually like a subject for stupids, kind of. So neural architecture for stupids. And I always read them because they make me understand the architecture very well. And it talks about it. It just explains the neural architecture search from scratch. I'll try to do the same thing in here now. So, but just visit these blogs if you're interested in these subjects, guys. So neural architecture search is the process of automatic architecture engineering. We know this, finding the design of our machine learning model. So we provide a neural architecture system with a dataset and task. whatever the task is, classification, regression, whatever. And it will provide us the architecture. I think we have the idea now. So neural architecture search can be seen as a subfield of auto-machine learning, which was already there. And we have auto-machine learning for 50 years. So from the beginning of machine learning, we had this idea, but it is new. It's new in a sense that we are getting very good results with it. So it has significant overlap with automatic hyperparameter optimization. Because when you designed a network, you have designed, co-designed the architecture in a handcrafted manner, you have to train it, right? When you're training it, you need to just optimize your hyperparameters. This might sound a bit new to guys who haven't taken the previous semester's course, but when you're training, when you're doing training, you have to do some hyperparameter optimization. It is finding the right parameter. You can do it in an automatic manner. So finding the automatic architecture is actually something similar to finding the hyperparameters automatically for your model. Okay, we'll get there. And neural architectural search simply finds an architecture from all possible architectures by following a search strategy which will maximize the performance. So it has three main parts. You have a search space of possible architectures. You have a search strategy within this architecture, and this search strategy will maximize the performance for you. So the best training result, the architecture with the best training result, will be the winner. Good. So in their paper, Neural Architecture Search Survey, it's a very new survey, guys, because neural architecture papers are like 3 or 4 year olds. So after Alex said the neural architecture search as an idea started like in 2015. So it's a new field, just like deep learning, and it's newer than deep learning. And we have a very new survey. It's a very valuable survey. Just find it and go read it, guys. It's a very nice paper. It's by some guys in Germany. You'll find very interesting things if you're interested in the subject, whatever. So let's continue. So what we said was neural architecture search has 3 main steps. We have a search space. We find the architecture from all possible architectures within the search space. We search for an architecture in the search space with a strategy. So how are you going to search? You will do a random search. Well, random search doesn't look like a good idea. Maybe if you had a strategy to search something, that would have been better. We'll go over those strategies. And while you're searching, you look for the best performance. So you just check the performance. But how do you check the performance? Train each of them separately. Well, this will take a lot of time. Maybe if you could find a better way, you'll be doing the things much faster. So you have a search space. You have a search strategy to find an architecture A in the search space. So architecture A, check the performance. According to the performance estimate of the A, search for another one in the search space. That's the idea. So this is an abstract illustration of neural architecture search methods. This figure is taken from this survey. A search strategy selects an architecture A in a predefined space A. The architecture is passed on the performance estimation strategy, and you just iteratively find a nice architecture. Okay, let's continue. Let's try to understand these 3 fundamental steps now, guys.